Hello friends, welcome to our channel where we are providing ECZ tailored lessons, right? Of course not exams, but lessons. So in this lesson we continue dealing with vectors, but our interest is to deal with these three. It's a continuation of vector geometry. Okay, so I want to see how we can bring our concepts together. So in the first question we are saying, in the quadrilateral ABCD below, alright? AB is the vector A there, AD is B, BC is 2B, AE to AC is 1 to 3. So here it is 1. From A to C it is 3. Meaning that from E to C you're going to say 3 minus 1. So here you have got 2 excuse. Okay. Now, Roman numeral 1. So I'll say answers here. Roman numeral 1A. Now find in terms of A and or B. Okay? The first one is AE. Okay. So AE. I want to move from A to E. How can we move? A to B, B to E. But here we can't take it because we don't know. Or we move from A to G, G to C, C to E. This is not known. Hence, we can try to use the ratios. You know that from A to E is 1. Alright? But AE is lying on AC. Alright? So now, what is the ratio of AC? It is 3. So this is 1 over 3 of what? AC. Okay? Now, do we have AC? Do we have AC? We don't have it. So we must get AC. So we're going to say AC is equal to, how do we find AC? From A to C. We can move from A to B, B to C. So we are going to say AC is AB plus BC. Right? What is the AB? AB is A plus BC is a 2B. Alright? Okay, that's how we get this one. AC is equal to AB, AB plus BC, which is A plus 2B. Meaning that our AE will be equal to 1 over 3 of A plus 2B. This is what we are going to have. Or you can say A 1 over 3A plus 2 over 3B. Okay? Take note of that one. Take note of that one. That is our AE. That is our AE. Okay, so we are saying our AE has been found to be 1 over 3A plus 2 over 3B. Okay. So we go to the second one. Okay. What's the second one? BE. You have B, you want to go to E. How can you move? You can move from B to A to E. So BA plus AE plus AE. Alright? Or you can take another route as long as it is known. Okay, so now we are going to say this is equal to, what is BA? We are going against the direction, so it will be negative A. Plus, what is AE? AE is G. 1 over 3A plus 2 over 3B. Here is 3 over 1. Our denominator here will be 3. 1 by 3 will be 3. Alright? So here, 1 into 3 is 3. By negative A, negative 3A plus 3 into 3, 1 by A, you have A plus 2 over 3B. Okay? And our answer will be negative 2 over 3A plus 2 over 3b. This is our answer. Alright, so we are saying BE is negative 2 over 3a plus 2 over 3b. Alright, that's what we are talking about. We go to the next one. What's the next one? BD. C. BD. Want to move from B to D. So how do you move from B to A to D? So B, A plus A, D. The secret is that the first here and the last one, they should give you the vector you're looking for. So BD is equal to, what is BA? BA is a negative, right? It will be negative, both are going against the direction. So negative A plus, what is AD? AD is what? A. So take note, again here, we are saying our BD is equal to negative A plus B. Okay, this is what we have. Alright? So here we are done. We go to the next one. We want to show that, hence or otherwise, so that the points B, E, and G are collinear. This is the second one. Alright? We show that B, E, and G are collinear. Now, we can try to extend here. Alright? Even without doing that, but I'm just doing it so that you're able to imagine what we're talking about. So, if the points are collinear, then they must lie on the same line. If the vectors are collinear, then they must lie on the same directed line segment. So, we are saying we need to think of a way of showing that these are on a straight line. Now, I can say, suppose I find vector BG, alright? BG, alright? Then, I'll say, you have vector BE, you have vector ED. Do I have a way of multiplying this vector BD to produce this? Does it hold? If I'm able to do that, then the vectors will be collinear because one vector will be the multiple of the other. For vectors to be collinear, the vectors must be parallel. Being parallel means one vector should be a multiple of the other, and that you must have a common point. So now, I will say, okay, can I multiply a certain number, which is K, by BD, for example? BD. Does this hold? Does this hold? Alright? Does it hold? If it does, then you will conclude that the points are what? Collinear. So we can check. We are going to say, what is BD? Negative A plus B is equal to K. Alright? Is equal to K. Okay. Sorry? So, take note here. It's supposed to be BD. Alright? Take note. So, we have to check if this holds. Alright? So we say, okay, what is our BE? BE is negative 2 over 3A plus 2 over 3B. Okay. So if this is equal to that, it means this is equal to this part, this is equal to that part. You can try both or even one. Alright? So we're saying A is equal to negative 2 over 3AK. Alright? Or B is equal to 2 over 3BK. Alright? So, if you multiply both sides by 3, you have negative 3A here is equal to negative 2AK. Our interest is to solve for K. You divide by negative 2A and here negative 2A. Alright? What does this produce? This will produce, well, this and this will cancel 3 over what? Over 2. Alright, you can try this one. Alright? When you multiply this side and that side by 3, you have 3b is equal to 2bk. Alright? You divide by, because your interest is to get the constant k. You divide by 2b, and here you divide by what? 2b. So we have k that is equal to 3 over 2. So we have the same, and we have a constant. Meaning that we have a scalar that we can use to multiply with BE to produce the BD. Simply means that BD would have been produced by multiplying a scalar by that one. If that holds, then we are going to say BD and BE are parallel. Alright? Being parallel simply means they also lie on a straight line because they have got a common point. So we are saying this simply means that we have got our BD can be produced by saying, what is our K? It is 3 over 2 BE. You can even verify this. Okay? This holds. This is true, isn't it? If that holds, then we are saying, therefore, the points B, E, and D are collinear. Collinearity means they lie on the same straight line. Okay? And that is how we are going to do that one. Okay? That's how we do that one. Okay? Alright? Hello. So let's look at the second one. We are saying in the diagram below, ABC. ABC is a straight line, right? AB is 4p, 8p. AC is 4p plus 9q. Then BV, taken from B to V, it is negative 6p plus kq, right? And AM is equal to MB, meaning that this vector is equal to that one. So if from here to there, it is 8, it means this is 4 and that is 4. Alright? Good. So, this is 2, Roman numeral 1A. 1 find what? AM. So we are saying AM is half of AB. Because that is the midpoint, alright? So it's half of that. So this is half of what is AB? It is 8P. Alright? And this will be 4P. So you have 4 giving you 8. That's our answer there. B. What is B? AV. AV. You need to move from A to V. You move from A to B, B to V. I hope it is okay. A to B, AB plus BV. Okay? What is our AB? Our AB is 8P. Alright? Plus, what is our AV? BV. BV is, so I can even say, because of minus here, so I can even say minus 8P plus KQ. Alright? Simplifying that produces. Okay, so this minus that we have got 2P plus KQ, and that's your answer, alright? Then we go to Roman numeral 2. Roman numeral 2, so we are saying, given that AV again is given by HAC. Okay. Let's form, by forming an equation involving these, P, Q, H, and K, or otherwise, find the numerical values of K and H. It simply means K and H here are scalars, alright? Then these others are vectors. Okay, so we are saying, what does this mean? What that means is, we need to equate, what is our AV? Our AV is this one, alright? So we are going to say 2p plus kq is equal to h, open the bracket. What is our AC? Okay, our AC is here. Okay? Our AC is 4p plus 9q. Okay, so here you say 2p plus kq is equal to 4hp plus, you distribute here, plus 9hq, right? So it simply means this will be equal to that. And take note, our interest is to find what? To find this and this guy. So we are going to say 2p is equal to 4hep. Alright, we want to find h. We divide by 4p here. And the 4p here. Alright. So this will cancel. These two cancel. We have got p, that is equal to what? 1 over 2. Right? That is the answer. Take note, this is h, not p. Because we have cancelled 4p and 4p, remaining with what? Here. We've cancelled this and this one, remaining with h, which is this one. Alright? So h is half. Okay? The next one, what are we supposed to find? K, is it? Yes. So we are saying K, Q is equal to 9Q, right? Okay, this is what we are supposed to have. Alright? There is H here. Take note. There is H here. We are given KQ and 9HQ. Okay? So we have KQ, that is equal to 9. This is 9. 9 HQ. Alright. Then I'll say my interest is to get what? K. So I'll divide by Q, and here you divide by what? By Q, alright? So this and this will cancel. Our K shall be equal to 9 what? 9H, alright? But what is our H? But H is equal to 1 over 2. Alright? You see how simple these things are? Alright, so we do the substitution. Alright, this implies that our K will be equal to 9 times our H is 1 over 2. Okay, so our K will be equal to 2 into 9, 4. What's the remainder? 1 over 2. Then we are done. So therefore, H is half and K is 4, 1 over 2. Question 2 is done. So basically that's how you get these things. Okay? Let's go to the third one. Okay, so number 3. We are saying relative to the origin 0, 0. The position vectors of A are OA, which is 9, 0, and OB, 3, 6, respectively. Right. The points D and E are on AB and OA, respectively. AD is 1 over 3 of OAB. OE is 1 over 3 of OA. The following diagram illustrates this information. So we are saying AD from A to D. This is the 1 over 3 of AB. So here there is 1. And from here to there it is 3. So this one will be 2. That one is the 2. Right? Then OE OE is equal to 1 over 3 of OA. So here again it is 2. 3 minus 1, you get your 2. So now we want A, alright? So that we get what? AB. Okay. We get AB. We want to move from A to B. So AB is equal to, okay, AB is equal to move from A to O to B. AO plus OB. Alright? Look, we have AO here, but what we have here is OA, meaning that it is negative. The negative of OA here plus. Alright? Because this is the origin, this is the position vector. You start from O to A, but you're starting from there. Alright? Plus OB. Okay, so AB is equal to negative 9 and this. Alright? So when you factor in the negative, then just be there. Okay? Because you can't put negative 0, say 0. Plus, what is our OB? Our OB has been given to be 3, 6. Alright? When you add here, negative 9 plus 3, 0 plus 6. So the answer here will be negative 6 and 6. So that one is your answer. Alright? Then B, OD. You want to move from O to D. Okay, so from O to D, you want this. Okay? So how can we move? We can move from O to A to D, from O to B, B to D, if at all we're able to do that. But I think the easiest is to go to OAAD. So we're going to say OA plus AAD. Okay? So, what is OA? OA is 9. 0 plus. What is AD? AD, we've been taught that AD is 1 over 3 of what? AB. Alright? So OD will be equal to 90 plus 1 over 3 of, what is our AD? AD is negative 6 and 6 here. So this will be equal to 9, 6 plus, what is the head of negative 6? So you have negative 2 and here you have 2, alright? So when you multiply this by that, you have got this one. So OD is equal to 9 minus 2, alright? Then 0 plus 2, because positive negative will produce a negative, alright? So what we get here, we get 7 and we get 2. This one is our answer. We got the third one. I hope it is okay. BE. BE. What is BE? We want to move from B to what? From B to E, here. Okay? So you can move from B to A and AE, or any other direction. Alright? Any other direction. Okay, so now we are going to say BO plus OE. What is our BO? BO is the negative of OB. So this is the negative of OB plus. What is OE? We've been told that OE is 1 over 3 of OA. Okay. So BE is equal to the negative of what? OB. What is our OB? 3, 6. 3, 6. It's supposed to be like that. When you distribute, there will be a negative here, right? Plus 1 over 3 of, what is OA? Our OA is 90. 90. This will be equal to negative 3, negative 6, plus a third of 9 is 3. A third of 0 is 0 itself. Okay. BE is equal to, what is negative 3? Plus 3, right? This plus that. Then negative 6 plus 0. This is 0 and negative 6. Basically, that's how you handle this. Alright, and that's where we end for this presentation. Thanks so much. Please, vectors are easy to understand. If you have liked our presentation, please subscribe and share. So I'm going to give you an exercise at the end of it all. Thanks so much.
Okay, so copy question 11. Copy question 11 nicely. This 70 here is the page number. 70 is the page number. Okay. 70 is the page number. So copy, as you can see, Roman numeral 1 is here. So you handle this question. Then from this Roman numeral 1, you come to these questions here. Copy these questions. It's a continuation. So this one. Okay. So these are the questions that you need to continue. Take note. This is Y here. This is Y. Okay. You have P, Q, K, and the rest. Let me take you to the second question. I think the first question is done here. Okay, so copy question 10. Copy question 10. This is your last question. And the table is shown below here. Alright, thank you so much for watching. Don't forget to subscribe and share.